So in this video, we are going to discuss what is regularization, what are the different type of regularization, and what's the benefit of using regularization as compared to if we don't use it during model fitment. So regularization is a technique to prevent overfitting by penalizing the complex models. What do we mean by complex models? So let's say you have some data set and you are training a model on top of it, and one of your model has two parameters, another model has five parameters. So as the number of parameters increase, we say that the complexity of the model has increased. Okay, so what regularization do, it try to minimize the complexity of the model by penalizing any extra coefficient, any extra parameters that we have introduced in the model while training. So basically it helps prevent the overfitting of the model. Okay, so it means if some data require only 3-degree polynomial to be fitted with, and if we try to fit that same data with a 5-degree polynomial, regularization will help us in fixing that problem. Okay, so how regularization is going to help us, I am going to explain using some toy data set. So look at this data set. We have x-axis here and y-axis here. Okay, if you see, a straight line may very well fit this data. Okay, a straight line which is moving from like this. Okay, or maybe a quadratic. Okay, but let's say you decided that I am going to create a model which will be a 5-degree polynomial and try to fit that 5-degree polynomial in here. It will try to fit this 5-degree this data like by passing through as many points as possible so that it can minimize the mean square error. Okay, but that 5-degree polynomial may not be a good model because it may fit this input data set very well, but it may not generalize well. So that's where the regularization help us. So what regularization will do, let's say we are trying to fit a 5-degree polynomial to this data. Regularization will automatically adjust to weights in such a way that the model complexity has been reduced. Okay, how it will do that? So maybe if we use regularization while fitting this model, it may make these weights W3, W4 and W5 as 0. So eventually this model which seems like a 5-degree polynomial, which turn into a quadratic polynomial, a quadratic equation. Okay, maybe it reduce W2 also to a very lower value, then it becomes more or less like a linear line where W1 has the significant value, W3, W4, W5 are 0 and W2 has very small value. So that's how regularization help. So if somebody asks you what does regularization do while model fitment, it actually try to reduce the complexity of your model as much as possible. So if your data set is not complex, it don't have a complex pattern involved in it, it will make sure regularization will make sure it only make model as complex as required, not more than that. That's how regulation help us. Now let's try to fit our model without regularization first. Okay, so we are not going to do any regularization. We're going to fit a 5-degree polynomial equation into our toy data set and see how it looks. Okay, so here I have imported all the required libraries. Here I have generated the toy data set. Then I am plotting that toy data set. After that I am defining a 5-degree polynomial equation here. Then we are fitting that 5-degree polynomial equation. We are doing a prediction, and after plotting those predictions on the curve. Okay, so this was our original noisy data set. Okay, now we fitted a 5-degree polynomial in it, and this is how it looks. We do regularization in two ways. The first way to do regularization is L1 regularization, also known as Lasso, and second way is L2 regularization, that is RAGE. If someone asks you what is the difference between L1 regularization and L2 regularization, okay, so the difference is the way we apply the penalty term. Okay, in L1 regularization, if you see the weights in this equation, W1, W2 up to W5, okay, in L1 regularization, the absolute value of the weights will be used to apply the penalty, while in L2 regularization, the square of the coefficients, the square of the weights will be used for applying the penalty. That's the main difference. Okay, so how it will impact the overall calculation? In L1 regularization, since we are using absolute value of the coefficients, so it may lead to some of the coefficients becoming 0. So it kind of works as a feature selection algorithm. L1 regularization is useful, let's say when you have a lot of features in your training data and you know that some of the features are not relevant and you want to get rid of some of the features, then L1 regularization will work well. Use cases where L1 regularization will work well is, let's say you have a text classification problem where each word actually become a feature. Okay, so by using L1 regularization, you can identify those words which don't have much impact on the classification task and you can get rid of those words. Since L2 regularization use squares of the coefficients to penalize the model, it is not useful in getting rid of extra features, but it is useful when you want to avoid the overfitting. So in practice, what you can do is you can use the combination of both L1 and L2. It is known as elastic net. And what benefit it will bring in? It will help you reduce unnecessary features from your model, but it will also help you reduce the overfitting of the model. So you can use the combination of L1 and L2 known as elastic net. I have given a simple example to implement this. You can check here. You can use the scikit learn library. You can tune the hyperparameters, and then using the elastic net regularization, you can get the benefit of both the words, getting rid of unnecessary features plus reducing the overfitting. Now let me show you the practical implementation of regularization, L1 regularization, L2 regularization, how it impact your fittings. So we are going to look into all of this. Okay, don't worry about this code, copying this code. I will be sharing the notebook link. So for now you just focus on understanding the code, what each part of the code is doing. Okay, I'll be sharing this notebook file with you, so you can look into the code, re-implement it whenever you want. Okay, so first we are going to import all the relevant libraries here. Then we are going to generate the toy dataset just like we generated earlier. Here we are plotting the toy dataset. Now we are defining a 10-degree polynomial for fitting the model. Okay, so I have taken a very high degree polynomial just to show you how high degree polynomial will lead to overfitting of the model. Okay, so I have used a 10-degree polynomial. I have not used any regularization while fitting the model. Okay, then I have used the Lasso regularization and ridge regularization. Okay, I have done fitting using those models also. Now we are going to do is we are going to draw our raw data. We are going to draw the 10-degree polynomial fit, L1 polynomial fit, L2 polynomial fit, and we are going to compare and see how it looks. Okay, so here we are evaluating our model. Now look at this part. This is the original noisy data, no fitting at all right now. Okay, next here, Okay, on the data I have plotted our 10-degree polynomial, this dotted red line, then L1 regularization green line, and L2 regularization yellow line. You can see this model without the regularization, it has overfitted the model a lot. Okay, you can see all these curvatures. It is trying to fit model to maximum number of points as possible. Okay, while L1 regularization and L2 regularization, you see those are more generalized models. So whenever we throw some unseen data towards these three models without regularization 1 and with L1 and L2 regularization, okay, definitely these L1 and L2 regularization models are going to perform much better than this overfitted red dotted line models. Okay, so that's the main benefit of regularization. You generalize your model on the training data set so that it performs well on the test data set, and you avoid the overfitting, and you get rid of the unnecessary features in your model, right? So one of the regulation get rid of the unnecessary features, other regulation take care of overfitting. If you take a hybrid approach, you use the elastic net, use both L1 and L2 regularization.